For today, we are going to calculate the reciprocal of a number that is very close to 1. It is not that difficult. You may press the calculator and see whether you can find the pattern. Please have a good try before you look at the explanation.
Pause the video now if you wish to solve it. Keep watching the video once ready.
Now, after you press calculator, then you know that this answer is actually equals to 1.00178. And for this is 1.000279. And for this, it is 0.9998876. And lastly, this is 0.998777. Now, if you actually press the calculator, you agree with me with the first, second, third, but not the fourth, because the calculator will give you 0.998778 instead of the 7 at the last digit. All this is only correct up to the decimal place that I show here. There are still many digits at the back. Okay, so now, what is the pattern for this? It is not difficult to observe that the pattern is equals to, if x is very close to 1, then 1 over x is very close to 2 minus x. So whatever I do, I will just take 2 minus the number here. And this is the result. Next, we are going to use 2 to 3 methods to show why this is true. If you enjoyed this video, please like, comment, and subscribe. The first method is rather simple. Since x is very close to 1, we will suppose x minus 1 square very close to 0, and it can be ignored. So when we expand it, it will be x squared minus 2x plus 1 approximate to 0. So 1 will be approximate to 2x minus x squared. And this is equal to x 2 minus x. And therefore, 1 over x is approximate to 2 minus x. This is first method that we have. One similar method to this is when x very close to 1, 1 over x is approximate to 2 minus x. Or we can say that 1 over 1 plus u is very close to 1 minus u if u is very close to 0. With the same reasoning, u is very close to 0, u squared is very close to 0. So 1 minus u squared very close to 1. And this is 1 plus u, 1 minus u, very close to 1. And therefore, the result. Next, we are going to use the binomial theorem to get this result. And not only that, we also will know what is the error bound. We need to know that 1 plus x to the power of n, it is equal to 1 plus nx plus n minus 1 over 2 factorial x squared, and so on and so forth. 1 over x can be written as 1 over 1 plus x minus 1. And this is equal to 1 plus x minus 1 to the power of negative 1. So using the formula, this is equal to 1 plus nx. N is equal to negative 1 and x is x minus 1. And plus n is equal to negative 1, n minus 1 is negative 2 over 2 factorial, and x is x minus 1 squared. So we can just approximate these two. The first two terms, 1 minus x plus 1, so it's 2 minus x. And for this, it will be x minus 1 squared. Of course, this is true with the condition that this x is less than 1. And also for this, x minus 1 is less than 1. So if this is very close to 0, that it will be better because all the terms at the back can be ignored. And therefore now we have 1 over x is very close to 2 minus x. And again, for the expansion of this binomial series, this is an alternating series where the absolute value decreases to 0. So the error is not more than this term. So now we prove that when x is very close to 1, 1 over x is very close to 2 minus x. However, this may not be that accurate if the x is not very close to 1. For example, use 1 over 1.12. Then it will be, using this formula, is 0.88. But the actual value, up to 2 decimal place, the answer is 0.89. We also know that the approximate value 2 minus x is always slightly less than the actual value. We also can see this via the graph of y equals to 1 over x. The graph of y equals to 1 over x, where x is positive, this is y equals to 1 over x, and the graph of y equals to 2 minus x. This is 1. Y equals to 2 minus x is actually the tangent to the curve y equals to 1 over x at x equals to 1. And the approximate value that we take from 2 minus x is always smaller than the actual value 1 over x. With this idea, actually we can get a more general term, but it is not as simple as this one. Say for example, 1 over 2.000123. It can be approximate to 1 over 2 minus 0.000123 over 2 square. And this is equal to 0.5 minus 0.0000375. And this is 0.499996925. This is so is because we can always write this as 1 over a plus b, where b is very close to 0 and a is an integer. So this will be equal to a plus b to the power of -1. And we can take out the a because of -1. 1 over a, 1 plus b over a. We can just take the first two terms of the binomial series. That is 1 over a, 1 minus b over a. So this will be 1 over a minus b over a squared. This is extremely useful when a is equals to 1, as what we have here. So that's all for today's lesson. I'll see you again next time. Bye bye.